Alrighty, guys, I'm gonna get started. Hopefully everyone is gonna join us soon, but I'm gonna get this show on the road. So remember what we have been talking about so far is sequences and series. We have looked at quadratic sequences, arithmetic sequences, and geometric sequences. And then last week, Wednesday, we started speaking about series, where we are now adding terms together of a sequence in order to figure out its sum. That's what a series is, the addition of terms. So on Wednesday, we spoke about arithmetic series, and today what we're going to chat about is geometric series. And this is going to lead us on into Wednesday's lesson, where we start seeing that there are certain geometric series that when we add their terms together, something quite cool happens. And we're going to explore that a little bit more on Wednesday. Right, but for now, we're just looking at geometric series. How do we add terms of a geometric series? What types of questions am I going to be asked? So before we get into our examples and our questions that we have, there's a few things that we just need to bear in mind and that we need to remember as we go along this journey with geometric series. The first thing is that any geometric number pattern has that constant ratio. Now remember, your constant ratio is the R value in your formulas that we work with. And in order for us to work out, or in order for us to determine an R value, what we need to do is we need to have term 2 divided by term 1, or you could have term 3 divided by term 2, etc., etc., etc. Okay, as long as you've got two consecutive terms, you can find your ratio. So that's the first thing that we need to know. The second thing that we always just need to bear in mind is the formulas that we do know that relate to our specific sequence or series. So thus far, we know Tn is equal to A times R to the power n minus 1. And we know that A is your first term, and R is that ratio that we've just spoken about. And this is important to remember because even though we are doing series, even though we're adding together the terms, it doesn't mean that this formula is no longer useful to us. It definitely is, depending on the type of question we get. And so we always need to have it in the back of our mind because it could potentially be, like I say, useful as we start to go along, and you're going to see that a bit later. So that's what we know. We should know all of this. Remember, guys, this formula is on your formula sheet, and on the Google Classroom, I've uploaded like a breakdown of your formula sheet in terms of highlighting your different bits of information that you've been given and saying, this is for sequences and series. This is for trig. This is for analytical, etc., etc., etc. The thing that we don't yet know, obviously some of you have already done this at school, so some of you do know, but assuming that this is the first time you've ever heard of a geometric series, the thing that we don't yet know is our sum formula. Now, the sum of a geometric series is A times R to the power n minus 1 all over R minus 1. And this is the formula that we're going to work with a lot this evening. Again, it's on your formula sheet. You don't need to memorize it. If you feel you want to memorize it, by all means, go for it. You don't have to. But it is there on your formula sheet. And remember, guys, this Sn means the sum of your series. So if we had S of, I don't know, 70, it would be the sum of the first 70 terms in the specific series you're talking about. Right, so these are all things that we should know or that we're going to learn about, especially this last formula, and we're now going to put this into practice. So I'm just going to wait here in case anyone does want to screenshot all of this. Otherwise, I'm going to go to example 1 and we're going to have a look. Alrighty. Sorry if you heard that. It's a massive shift. Okay. Right, let's have a look at example 1. So we have got evaluate 1 plus 2 plus 4 plus etc., etc., etc. to 10 terms. So firstly, when it says evaluate, this isn't anything that we need to stress over. It's basically just saying calculate the sum or calculate the value of. Just means calculate. So evaluate 1 plus 2 plus 4 plus blah, blah, blah means find the sum of 1 plus 2 plus 4, blah, 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 of this geometric series to 10 terms. Okay, so that means we're going to have to use our formula that I've just mentioned to you, and I'm going to write it down a few times, so it's going to eventually stick in your heads. There it is again. And remember, for us to be able to use this formula, we need 2 bits of information. We need A and we need R. As long as you've got those 2 bits of information, we are going to be fine. A is your first term, so that's what I have. No stress there. I've got nothing I need to worry about. That's right there. But R, we need to go and work out. Now, this is quite an easy R value. You don't even need to show this ratio because it is quite easy. But it would be term 2, which is 2, divided by term 1. And so your R value here is 2. It would be the same if you said 4 divided by 2. You still get that constant ratio, which is why it's a constant ratio. So we have all of the information that we need, and we can go and substitute into our formula. So I want the sum of the first 10 terms, which means I've got A, which is 1, open bracket 2, because that's R, to the power of 10 minus 1, all over 2 minus 1. Now, guys, this 1 in front of that bracket actually does nothing, because 1 times anything doesn't change the value. Obviously, you leave it there, it's absolutely fine. But because you've now substituted in everything, all you do is you put that into your, and you said into your formula, into your calculator, and you get your sum. And in this case, it's 1023. If we add the first 10 terms together, that is the sum that we end up getting. So really, when it comes to the sum formula, actually with all of our formulas, once we have all the information we need, it's really not hard to go and solve for what we want. As with everything in maths, we have to read our questions carefully, because as you see, as we start to move on in complexity here, we don't read the questions carefully, we're going to make an oops. But once we have our information, it's a simple subbing into a formula and solving for our unknown. All right, so I'm going to do example 2, and then I'll make it a bit smaller for you to screenshot both. Example 2 is saying find the sum of the first 12 terms of the series 2/3 plus 2 plus 6 plus blah, blah, blah. Now, this question is asked a bit differently because it's telling us we want the first 12 terms. It's not using that evaluate phrase, but it means exactly the same thing. We're doing exactly the same thing. So remember, A is your 2/3. We do need to go and work out R because it's not as simple this time. Now, Gretel's, you've got options here. Remember, you can either say term 2 over term 1, or you could say term 3 over term 2, etc., etc. Now, term 2 divided by term 1 would be 2 divided by 2/3. That's fine. You have a calculator, you type it into the calculator, you get your answer. But you could also have term 3, which is 6 divided by term 2. And that's much easier to see that your common ratio, or constant ratio rather, is 3. It makes no difference though. Because it's a constant ratio, you will get the same answers. So 2 divided by 2/3 is 3. 6 divided by 2, we know is 3. So that's why I always say to you, it doesn't matter which terms you're dividing, as long as you're keeping them consecutive. Term 2 divided by term 1, term 3 divided by term 2, etc., etc. So if you can easily see that your common ratio is 3 by rather looking at term 3 divided by term 2, fine. Whatever, it makes no difference, you will get your answer. However, we now have A and R, which is all we need for our sum. So the sum of the first 12 terms is equal to 2 over 3 times R, so times 3 to the power of 12 minus 1 all over 3 minus 1. Now, Gretel's, please just be careful when you do go and substitute this into your formula, because obviously now you've got a fraction in a fraction. So just be careful when you do put it in on your calculator. You shouldn't have a problem, but just be mindful of it. Alrighty, so chuck that into your calculator. In the chat, let me know what you get as your sum. Oh, excuse me. Yes, like I say, let me know in the chat what you get as your sum once you put that into your calculator. And guys, you can write your answers as fractions or as decimals. It really doesn't matter. Both are fine. One answer, grade 12. I refuse to believe that. All right, I'm not too sure why we're not volunteering answers, but that's fine. What I do just want to do is I want to do the substitution on the calculator with you because of the answer I did get. You just need to be careful. So let's just open the calculator. Oh, God. Okay, so if we have a look at our calculator, there it is. We are substituting in our formula. So we want to have our fraction. Now remember, you've got a fraction in a fraction. So 2 over 3. And then we're going to open our brackets. 3 to the power of 12 minus 1. Oops, let's try that again. Minus 1. Close our bracket all over 3 minus 1. So be mindful of that when you type it in. And we get this 531,440 over 3. If you want to make that a decimal, 177,146,67. So please just be careful when you do sub in and type it into your calculator. That fraction within a fraction can get a bit tricky. And just be careful because in our original sequence that we had, our original series, which should be coming back to you relatively soon. There we go. In our original series that we had, our very first term was a fraction. So that does give us an indication that even though we're going to add a whole bunch of whole numbers, my answer should have a decimal to it, all right, because of that 2 over 3. So when we go and sub that into a calculator, as we just saw, we get that 530 gross thing, 531,440 over 3. Or if you want to write it as 177,146,67, that is absolutely fine as well. Remember, both are fine. You will get full marks for both. No problem either way, whatever you prefer at the end of the day. Alrighty, guys. So that one, not tricky. Just be careful of your substitution. All right, so I said I'd let you screenshot the first 2. So there you go. Let's screenshot those, and then you're going to have ones to try by yourself. Remember, same as usual, if you're new, you're going to get 2 options, one easy, one medium. You decide which one you're at based on how you feel geometric series is going for you. If you finish the first one, do the second one. So you're more than welcome to do both. You don't have to only do one, but I am giving an option in case you're not feeling super comfortable. Okay, so here are your two questions. The easier one or the slightly harder one, you decide which you prefer. I'm going to give you 5 minutes and then we will, let's say 3 minutes, and then I'll check in and see where you're at, and then we will have a look at answers. And guys, remember, feel free to put your answers on the chat. Might help someone. I can then also see how we're doing. And remember, if you've got questions, you're more than welcome to unmute yourself, or you can pop them in the chat, or you can send me a message and I'll help you. Grade 12, so you just give me a thumbs up in the chat or reaction when you're done, just so that I can see if you still need some time. Thank you, Kirsten. Guys, remember those thumbs up when you're done, just so that I can sort of gauge how much time you need. The table, thank you. Tukozani, thank you. I saw your thumbs up as well. Manuel, thank you. Yeah, we're getting a few different answers here. So please be awake and alert when we go through the answers. I'm going to give you 1 more minute and then we're going to go through them. Alrighty, guys, let's have a look. Okay, so for the easy question, sorry, my brain just had a bit of a moment there. We're adding 2 over 27, 2 over 9, and 2/3. And we want to add the first 9 terms together. So what we need to know is A, which we have, but we do need to go and work out R. So just be mindful of that in terms of you have to go and work out what R is. But once you have R, you know it's 3, you substitute it into your formula, and you get this 19,682 over 27. Now that means very little. So as a decimal, that value is 728.96. Remember, both of them are fine. Don't mind if you leave it as a decimal. I don't mind if you leave it as a fraction. Up to you. You're not going to get it wrong either way. Alrighty, now this makes sense for this series because if you have a look, these numbers are getting bigger and bigger and bigger. So our sum should be hopefully getting bigger and bigger than the actual terms that we have here. So that's one way to sort of check and see if you're on the right track. So that becomes important now when we go to the medium question. So before I reveal the answer, your first term is -64, then +32, then -16, and then you'll get the rest. What's actually happening here is that you have a constant ratio that is negative. And so what that means is that you alternate between a negative term and a positive term, because the negative divided by negative is a positive, the positive divided by the negative ratio is negative, and so it keeps going like that. Now, because your negatives and your positives are essentially getting increasingly smaller, those negatives went from -64 to -16. The 32 is going to go from +32 to +8. They're still positive and they're still negative, but they are getting smaller and smaller and smaller. And so that should sort of go into our heads when we look at the sum. This was a slightly harder one for a reason. So there you go. That's exactly what I said now. Your R, or your constant ratio, is a negative value. When it alternates negative, positive, your R is going to be negative for the reasons I explained earlier. And then we substitute in. Now this -341/8 is -42.67. Let me just double check that decimal. 63, I do apologize. -42.63. Again, both of them absolutely fine. Decimal, fraction, whatever, it's completely up to you. Both are correct. You'll get both. Right, so guys, please do ask if you're not 100% sure where I've got some of these values from. Please do make corrections as we go along. But essentially, once you have R, you can substitute into your formula. Think about what the series is doing. So is it getting increasingly bigger, increasingly smaller? Have you got negatives? Have you got positives? Just to give you a bit of an indication of what your sum should look like. So I'm going to give you a second to screenshot. I'm also going to give you a second to just make sure you've gone through the answers. And that if you've got any questions, you are either asking me in the chat or you're unmuting yourself to ask me. Right, guys, and exactly as Kirsten said there, you can see that I've got a lot of brackets going on in my substitution. So for example, and particularly in this medium question, you need to remember that your base of R is -1/2. And so it's exactly what Kirsten said there. Remember to put in your brackets around what you substituted. This whole value of -1/2 is your R. So -1/2 should be to the power 10. Remember, we spoke about this a little while ago. If you have -2 to the power 2, that means something completely different to -2 in brackets to the power 2. Because what you have here in the first scenario is actually -1 times 2 squared, which gives you -4. Whereas in the second scenario, you actually have -2 times -2, which gives you a +4. And so exactly what Kirsten said there in the chat, if you forget those brackets around what you substituted, especially when your exponent is even, you're going to end up with weird answers. So please do remember your brackets. You've seen me use brackets every time I substitute. And it is something that we sort of emphasize in grade 8 and grade 9 when we do substitution. But just make it a habit. Whenever you substitute in a value, use brackets, even if it's not necessary. So even like here, I could have used brackets around the base of 3, so that R value of 3 makes no difference because of the sign being positive, but get into the habit of using brackets. Okay, let's have a look at our next example here. So example 3 says calculate the sum of the following finite geometric series: a quarter plus a half plus 1 plus 2 plus a whole bunch of terms plus 256. Alrighty, guys, so this is now back to what I said at the start of the lesson. Read your question carefully. Firstly, it says it is a finite geometric series. And we spoke about this when we did arithmetic. It ends, okay? It ends at 256. This is my last term that I'm going to add. So last term of the series, last term that I'm going to add, that's that. We have no idea how many terms are in between 2 and 256 that we need to add. So that's a bit of a problem, but let's deal with that as we need to. So we know that the series ends. That's the first thing. The second thing that I do know is my A value, because I know what the first term is. Second thing. The problem is I don't know yet what R is. That's an easy fix. So let's first go work out our R value, which would be a half divided by a quarter, or if you're not too keen on that and it's easier to say 1 divided by a half, whatever, as long as you're using consecutive terms. Either way, we get that our R value is a quarter. If you want to write it as 0.25, obviously absolutely fine as well. So we've got A, we've got R. We know that the series is going to end, and we have been asked to calculate the sum. Now, the problem is I have no idea how many terms I'm adding together, exactly what I said earlier. I don't know how many terms are in the series. I just know where it starts and where it ends. That's it. So when we get a question like this, we need to be very careful. Because I don't know what n is, I first need to find that out. It is not possible for me to go and calculate the sum of a series without knowing how many terms I'm adding. And now this is what I was saying right at the start of the lesson. Remember, you've got 2 formulas, and you need to now decide which is going to be useful to you. So I'm going to write them both down, and then we're going to decide which one is actually useful in this scenario. So we've got our Tn formula, and we have our Sn formula. Now we need to decide which is useful. Okay, so if I go to my sum formula, because at the end of the day, the question is saying calculate the sum. What did I say? Sorry, I see Josh's question on the chat. I've just gone sidetracked. Josh, you may very well be right, and I might be having a bit of brain fart. Yeah, R is 2, guys. Sorry. Who on earth knows what I was doing? So yes, a half divided by a quarter is 2 because 2 quarters make up a half. Thank you, Josh. Losing my mind today. Thank you very much. Alrighty, so let us continue. If I go to my sum formula first, I know A, and as Josh has corrected me, I now know R. But the problem is I don't know N, because remember, I don't know how many terms I'm adding, and I don't know the sum. I know that I have to find the sum, but because I've now got 2 unknowns, that's going to make that use of that formula very tricky. So let's go back to Tn. I know A, I know R, and I have the value of my last term. So technically, I know that the value of my term is 256, which means that the only unknown I actually have when using the Tn formula is n, and n is what I want to know. I want to know how many terms are in the series so that I know how many terms I'm adding. So we're going to use this. 256 is equal to A, which is a quarter, or 0.25. Josh, I think that's where I had my bit of an oopsie. I just looked at the first term and I just wasn't thinking straight. So thank you for correcting me. My R term is 2. I'm going to use my brackets, exactly as Kirsten told us to do. Use your brackets. N minus 1 in my exponent. Okay, so first things first, I don't want that quarter there. That is of no use to me. It's just in my way. I don't like it. It's gross. Let's get rid of it. Divide both sides by a quarter. That is now gone on the right-hand side. And 256 divided by a quarter is 1024, if I'm not mistaken, is equal to 2 to the power n minus 1. All right, now guys, remember back to your exponential equations that you've been doing since like grade 8. The goal is to make the bases the same. So this is already a base 2 on the right-hand side. So can I write 1024 with a base of 2? Tell me in the chat. 2 to the power what? Two to the power what is 1024? Ongenkosi, nice. 2 to the power 10 is 1024. And so we can now equate our exponents because the bases are equal. So I just need to get my exponents equal. And so n, as I think Kirsten had put there on the chat earlier, is equal to 11. So now I know, that's not my final answer. Now I know that there are 11 terms in the series. And so now when it comes to the sum of this finite series, that's easy. I want the sum of 11 terms. So A is a quarter times R, which is 2 to the power 11 minus 1 all over 2 minus 1. And we've got all the information we need. We put it into our formula. We put it into our calculator. And we get that the sum of these 11 terms in this finite series is 2047 over 4. Or, if you don't like that, 511,75 or 511 3/4, whatever you want. Alrighty, guys, so please be mindful of the information you're given. In this case, I was asked to find the sum, but I did not know how many terms I needed to add. I first needed to work out the number of terms before I could go and work out the sum of my series. And sorry, my brain is clearly a bit fraught today. R is 2, not a quarter. A is a quarter. Okay, so let's take screenshots. If you've got questions, please ask. You can unmute yourself. You can put it in the chat. And then let's have a look at example 4. So hot. Okay, let's see example 4. So example 4 says the sum of the first n terms in the series 3/4, 3/2, plus 3, plus blah, 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 is 23 1/4. So importantly, it says the sum is 23.25. So we've been given a value for the sum. Again, read the questions carefully. I've been asked to determine the value of n. So I'm being asked, how many terms are we adding? And so again, assess what you have. We have the sum, which means I could use the sum formula. Why not? This is different to example 3 in that I wasn't given the value of the last term like I was in example 3, but I am given the sum. So that's cool. Could use the sum formula. I know what A is. It's 3/4, and hopefully I can work out R this time. Let's give it a try. If I wanted to work out R, we could say 3/2 divided by 3/4, or if you don't like that, you could say term 3, which is 3, divided by term 2, which is 3/2, whichever you prefer. It is completely up to you. But we get an R value either way of 2. Do we agree with an R value of 2? Just because clearly me and R today are not friends. Okay, you'll tell me if I'm wrong, but I'm fairly certain this time I'm correct about my R value. So we have, thank you. It's been a long Monday. It's been the Mondayest of Mondays today. But anywho, that's a tangent. We have R. So we've got the sum, we've got A, we've got R. We are looking for N. So again, if we go and look at our two formulas, we've got our Tn formula, and we've got our Sn formula. Problem with Tn is I don't have Tn. So then I am solving for Tn and I'm trying to solve for N. That's silly. Why do I want to solve for two unknowns at the same time? So I don't want that. I have the sum, I have A, I have R, which means that the only bit of information I don't know in this formula is N. Great, that's what I want to look for. So in this case, I'm going to use the sum formula. So take note of the difference. In the last one, I gave you the value of the last term, whereas in this one, I'm giving you the sum. So always go with the information we give you. We don't give you useless information. So the sum is 23.25. I'm just going to write that as a decimal. You don't have to, it's up to you. Is equal to A, which is 3/4, open bracket your R value, which is 2. Some weird brackets going on there. To the power of N, which we don't know, minus 1 all over 2 minus 1. Now guys, 2 minus 1 is 1. So what we actually have is 23.25 is equal to 3/4 times 2 to the power n minus 1. And I will sort of do what we were doing earlier. I don't want the fraction there. Let's get rid of the fraction by dividing it away on both sides. And so what we end up with is 31 is equal to 2 to the power n minus 1. I'm going to carry on up here. Inverse operation says add 1 on both sides. So 32 is equal to 2 to the power n. And we know that 32 can be written as 2 to the power 5 is equal to 2 to the power n. And so n is equal to 5. And so what this means is that there are only 5 terms in the series if the sum is 23.25. So based on the information you have, you need to be very mindful of what formulas you can use and how you can use them. And this is, again, going back to read your question carefully. Is it the value of the term? Is it the sum of the terms? What have you been given and how can you now use it to find what you want? So let's take a screenshot of that and then you're going to try, or you're going to have you try by yourself. Again, a medium and a hard. You have 2 questions in the easy one, 1 question in the medium question. You decide which one you're at. If you want to do both, do both. I'm going to show you both answers so you can screenshot for both. Right, I hope we've got screenshots of this though. Let's have a look at your tries. Yes, there are your 2 questions. So the first one, I want to know in A, how many terms are there? And then in B, what is the sum of the series? Whereas in the medium question, I'm asking you how many terms in the series will add up to, so I'm giving you a sum of 20,475. I'll give you 5 minutes. I think these are slightly more complex than the first ones. Give it a try. Remember, if you've got questions, just unmute yourself and ask, or pop it in the chat, or send me a message, and I'll help you. Okay, guys, and remember, feel free to put answers in the chat exactly as Atia has done there. Might help your peers. Great, Tools. I'm loving these answers coming in so far. Thank you. Give you 1 more minute, and then we're going to go through the 2 answers. Alrighty, guys, let's have a look. Okay, so if we have a look at the easy one, again, remember there's two options here. You worked out your R value to be positive a half. Now we can see that it's going to be positive because remember, it's not that alternating negative, positive, negative, positive. So because they're all negative, your ratio has to be positive because we know that a positive divided by a negative will be a negative, or negative divided by a positive, however you want to look at it. So our constant ratio here is a half. You first have to work out how many terms in the series. There were 12, and your sum was the negative 4,095 over 32, or negative 127,97. Just here, the decimal was 96875. So to two decimal places, which we always round off to unless told otherwise, the 8 rounds the 6 up to a 7. So hence negative 127. I don't know what that was. Come on, 9. Oh gosh, I did it again. Okay, I'm not going to underline it. That's the answer. We're happy. Okay. If we look at the medium question, sorry, a little bit harder because you had to first, we're going to get there in the end. You had to obviously work out your R value, and then you had to realize that you were using the sum formula. You did not need to first use Tn to find the number of terms. You could just use your sum formula because in this case, I gave you what your terms are adding up to. So I gave you the sum. There was no reason to go and use the Tn formula in this case. But here you got that there were 12 terms that could add up to 20,475. Right, but take your screenshots, and we're going to have a look at one more example before we end off. And this is quite a nice example because we've been given information here. Now we need to analyze what we've been given and how we're going to use it. Okay, so let's see what we have. So, whoopsie. Example 5 says, in a geometric sequence, T1, so term 1 is equal to 1, and term 4 is equal to 27. Determine the sum of the first 10 terms. Okay, now we always panic when we get questions like this because we've been given random terms and now we want the sum. So now in our head we're thinking, but I don't know what terms I'm adding. Because I've got term 1 and term 4, I can't even work out what the ratio is by saying term 3 divided by term 2 or term 2 divided by term 1 because I don't have that information. And now I want to find the sum. Remember, guys, we give you information for a reason. All of the stuff that we have here is given to us for a reason. So let's go through what we've been given and decide why has it been given to us, and then how are we going to use what's been given to us to find the sum of the first 10 terms. So if I just start with term 1 equals 1, remember your sum formula is Sn is equal to A times R to the power n minus 1 all over R minus 1. In this formula, to work out the sum, we need A and we need R. We've been given A. We know that A is equal to 1. That has been given to us in the information. Sorted. So that's where I'm going to use T1 equals 1 as my A value. The next bit of information that I've been given is that term 4 is equal to 27. Now, why would they give me a random term? It doesn't help me find R because I can't get a ratio. So why have they given it to me? Well, let's see. I've been given a term value and I've got a term position. So really at this point, the only thing this could really go into is my Tn formula. So let's sub it in and see what happens. Tn, so the value is 27, is equal to A. Now we've just said that A is 1 times R to the power n is 4, so 4 minus 1. Look at that. I've set up an equation where I can now solve for R. Now that coefficient of 1 doesn't do anything. So what I actually have is 27 is equal to R to the power 3. We know that 27 can be written as 3 cubed. And so if my exponents are the same, my bases need to be the same. And so R is equal to 3. So by being given that term, I was able to work out what R is. So now I've got A, now I've got R, I can find my sum, no problem. So all I now do is substitute in the information I have. So A is 1. If you want to leave it out, it's fine. 1 doesn't make a difference in this case, but I am going to put it there. Times my R value, which is 3 to the power of 10, because remember we're looking for the sum of 10 terms, minus 1 all over, those are weird looking lines, so we'll try that again, all over 3 minus 1. And now because we've got all of that, we just put that into our calculator. And we get 29,524. Alrighty, so a person asks, how is R and 3 the same base? Okay, so guys, if we just go back to this, the situation over here where I've highlighted, this is still an exponential equation. It just looks a little bit different to what we used to. So usually what we want to do is we want to make the bases the same. But in this case, it's the base I'm actually looking for. So we almost need to go the other way around. We want to make sure that the exponents are the same, which in this case they are because they're both 3. And if your exponents are the same, in order for it to be equal, the bases have to be the same. So for example, silly thing, if I had 2 to the power 4 is equal to x to the power 4, the only way for that to be true is for both bases to also be 2. So it's almost like the reverse. Because my exponents are the same, my bases have to be the same in order for it to be equal. And so I know R is equal to 3. Kristen, I'm really glad it makes more sense now. Sorry, I just sort of went through that. I should have explained it a bit more, so thank you for calling me. But yeah, in exponential equation, we don't necessarily always have to solve for the exponent. Sometimes, it's not often, but sometimes we do need to solve for the base. And this was a good example of how or when we need to solve for the base in terms of finding R. Okay, so guys, what you can see is that there actually wasn't a lot of working out that I needed to do. I took the information that I had, I decided how it was useful to me, and then I went and took that information and did what I needed to do with that. Just to rehash that, term 1 is A. I have A. I can't apparently highlight. Apparently I'm not capable of doing that. Term 1, A, sorted. Term 4, random, but I can sub it into Tn and I can find R. I have A and R, I can go and work out my sum. So sequences and series, I mean maths in general, but it is so important we read our questions carefully to actually analyze what information we've been given. Alrighty guys, but I'm going to leave that there.